Have you ever noticed how bean sprouts seem to grow almost overnight? You soak tiny seeds before bed, and by morning they've transformed into long, crunchy sprouts. No sunlight, no soil, yet they grow at lightning speed. How is that possible? Today, we're diving into the secret science behind this rapid transformation. Inside, every seed is a blueprint and a packed lunch, just waiting for water to flip the on switch. We'll unpack the energy, the mechanics, and why darkness is actually an advantage. Let's get started. To understand their speed, let's start with what a bean sprout actually is. When you see a sprout, you're witnessing the very first stage of a plant's life: germination. The dry bean is a seed, a protective package with a plant embryo and its food supply, called cotyledons. Soaking the seed lets water in, waking the embryo from dormancy. Enzymes activate, breaking down stored nutrients into simple, usable energy. The first thing to emerge is the radicle, or root, which absorbs more water for rapid growth. The sprout is burning through its stored energy, not making new energy from sunlight yet. This is why it grows so explosively. Everything it needs is already inside. All we do is add water and watch the transformation. The seed's efficiency is the first clue to its rapid growth. It's a plant in its most dynamic, high-speed phase. The sprout is using its inheritance to get a head start. That's the secret to its overnight miracle. Think of the seed as a preloaded battery, packed with energy-rich starches, proteins, and fats. When water activates the seed, enzymes break down starches into glucose, proteins into amino acids, and fats into fatty acids. The sprout doesn't rely on sunlight yet. It's living off its internal reserves. This allows for a burst of growth that's impossible for mature plants. The energy is so concentrated, the sprout can double in size in a day or two. It's a closed system. Food, blueprint, and water are all it needs to execute its mission: grow fast and find light. The balance of carbs, proteins, and fats ensures the sprout has both fuel and building blocks. When you see a sprout shoot up overnight, you're witnessing this battery in action. The sprout is rapidly converting stored matter into new growth. It's a masterclass in energy conversion. This is the core reason for the sprout's speed. The miracle is all about using what's already there. That's how the overnight transformation happens. Here's the real trick. Bean sprouts don't just make new cells, they stretch the ones they have. Most of the growth comes from cell elongation, not cell division. Imagine inflating a chain of tiny balloons instead of adding more balloons. That's how sprouts grow fast. Water fills the cells, creating turgor pressure that stretches them. Growth hormones called auxins loosen the cell walls, letting them expand. Once stretched, new cell wall material locks in the new size. This process is fast and energy efficient. The sprout is literally inflating itself upward, using water and hormones. It's a shortcut. Instead of building brick by brick, it stretches what's already there. This is why sprouts can grow inches in just days. Rapid cell elongation is the physical engine behind their speed. It's a brilliant biological hack for fast growth. That's the secret to their lightning-fast transformation. Why do bean sprouts grow best in darkness? It's all about survival. In the dark, the sprout enters etiolation, a desperate sprint to find light before its energy runs out. The plant pours everything into rapid stem elongation, not leaves or chlorophyll. Darkness triggers more auxin production, loosening cell walls for even faster stretching. The result? Long, pale, tender sprouts. Light actually slows this process, signaling the plant to switch to normal growth. For us, this means longer, crunchier, and more delicate sprouts. By sprouting beans in the dark, we're tricking the plant into its fastest growth mode. The darkness isn't just a preference, it's the trigger for maximum speed. Etiolation is nature's way of helping the sprout break through soil. For humans, it's the secret to perfect bean sprouts. The plant's panic mode is our culinary advantage. That's why darkness matters. Water and stored energy aren't enough. The sprout also needs oxygen. Cellular respiration turns glucose and oxygen into ATP, the energy every cell uses. Sprouts grow so fast, their metabolism is in overdrive, demanding constant oxygen. If deprived of oxygen, like in stagnant water, growth stops and rot sets in. That's why rinsing and draining sprouts is crucial. It brings in fresh air and removes waste. Air spaces in the jar let oxygen reach every sprout. Without enough oxygen, the biological engine stalls. The need for constant rinsing reflects the sprout's intense, non-stop respiration. Oxygen is the key that unlocks the seed's energy. Fast growth depends on a steady supply. That's the hidden reason behind every healthy sprout. Water is more than a trigger, it's the engine of sprout growth. First, water wakes the seed, activating enzymes and starting metabolism. Second, it's the transport system, moving nutrients to where they're needed. Third, water physically inflates the cells, driving rapid elongation. A sprout is up to 90% water by weight. Growth is mostly about water uptake. Keeping sprouts moist but not submerged is critical for turgor pressure and expansion. If they dry out, growth stops instantly. Water lets the plant gain size with minimal new material. Every step of the sprout's journey is powered by water. It's the substance that turns a dormant seed into a living plant. Water is woven into every phase of this high-speed transformation. That's why it's the true engine of growth. Why are bean sprouts so tender? They sacrifice defense for speed. Mature plants build tough fibers and chemical defenses, but sprouts skip these steps. They don't waste energy on lignin or toxins. They focus on rapid elongation. The result? Thin, flexible cell walls and a crisp, mild taste. Their main defense is to outgrow threats, not fight them. This makes them vulnerable to bacteria, so food safety is crucial. Always rinse and use clean equipment. The sprout's tenderness is a direct result of its live fast, die young strategy. It's a high-stakes gamble. Reach the light before getting eaten or infected. For us, it means a delicious, crunchy vegetable. For the plant, it's a race against time. Speed wins over strength in the world of sprouts. That's why they're so delicate and so tasty. Why do we love bean sprouts? Their rapid growth transforms them into nutritional powerhouses. Germination breaks down starches and proteins, making nutrients more digestible. Sprouting increases vitamins like C and B and makes minerals more accessible. The result? A tender, vitamin-rich, easy-to-digest food. In just days, you can grow fresh, living food on your countertop. The sprout's speed is part of its appeal, urban farming made simple. We're hijacking the plant's own life-giving process for our benefit. The journey from seed to sprout is a masterclass in efficiency. It's fast food in the best sense, packed with nutrition and vitality. That's why bean sprouts are a staple in kitchens worldwide. Next time you see bean sprouts, remember, they're tiny marvels of biology. Every aspect, from stored energy to cell elongation, is optimized for speed. This transformation happens right in your kitchen, with just water and time. The humble sprout is a testament to the explosive power of life. Thanks for joining me. If you enjoyed this, like and subscribe for more science adventures. Until next time, stay curious.